Hello everyone. So let me share my screen with you. Sharing the screen, sharing the screen. So today we look at a new topic, which is arrays and objects. Basically, reference type. Whether it is an array or an object, the type of for the variable that you declare normally is reference. You already know it. I've shown you many times that class type always have a reference variable. For example, a class called dog, a class dog, when you declare a dog, for example, dog D, this is a reference variable equals to new dog. This is a method, the constructor method, constructor. It's a method, it's a special method. Every class has a constructor method. Whether you define or you don't define, the constructor is always there. So it will allocate a memory for D, which is reference. Reference is always the same size. It will refer to an object. The real dog object is here. This is the object, the dog object. And it will be pointing to that object or referring to the object. The best way is to say reference, referring to the object. So this variable is reference variable. So the size of this object is the size of the class dog. If you go somewhere, that dog class is defined. Class dog, curly brace, set of variables, and set of methods. The size of the object is the size of the variables. The size of the variable, the total size of the variables is the total size of the object in terms of memory. So that's about defining objects. What about arrays? Array is a sequence of similar elements, similar elements, similar elements. So set of similar elements, set of similar elements. What can be an element? Element can be an integer, double, long, any primitive type or reference type, anything, objects. But array itself is a reference. Let me define it for you. Integer, you put a square bracket here, x equal to, you have to define set of integers. It allows you to write down in a C type of definition here, because a primitive type is an array of, so 153, 25, 7, 82. For example, curly brace, close curly brace. There are 4 elements, all are integers. You cannot mix them. Double and integer cannot be mixed. It's either all integers or all double. So this variable x is a reference variable. When you write down integer x, integer a is a variable, a is an integer, this is 4 bytes. Whereas this one x is a reference type, reference. X is reference. To what? To set of integers. So there are 4 integers here. The size of this one is for the 4 integers. which means that each integer is 4 bytes, 4 bytes, 4 bytes, 4 bytes, 16 bytes put together. You can write down 53, 25, 7, 82. You can directly, the real integers are here, whereas x is referring to those integers. So x of 0 is the first integer. X of 1 is the second integer. X of 2 is the third integer. X of 4 plus x of 3 is the fourth integer. X of 3 is the fourth integer. So if you want to get the integers, you have to write down like that. So these are exactly similar to the A here. That is one integer. This is one integer. This is another integer. This is another integer. This is another integer. The x itself is not an integer. It's a reference to integers. Exactly the same way for all of them. So let's move ahead. You will see the more details. Reference type arrays. So basically, array is a fixed number of elements of the same type. We call them elements. The order matters because indexing, we are indexing them. So hide the floating panel, hide the video panel. Okay, okay. So let's move ahead here and then try to clean up and more. Order matters because you are indexing them. So x of 0, x of 1, so the first one, second one, third one, like that. So, once you create an array, the size cannot be changed. What does that mean, sir? Integer, an array, x equal to 5, 3, 2, 1. For example, the four integers. So that means memory will be allocated for x, which is a reference. Reference. It will be referring to the four integers, which is going to be 16 bytes. So that means 5, 3, 2, 1. So this size cannot be increased or decreased once you allocate. It cannot be changed. So all elements must be of the same type. I hope you understood so far. These are the rules of the game. So whenever you see the square bracket, immediately you should recognize this is an array of whatever type it is. Array. And the variable here is a reference variable. All array variables are reference variables. And the elements are the ones which are actually the real values. You have already seen earlier string args. String is a class. We already know string is a class. So that means it's creating an object. If you write down a string, for example, string x equal to hello. So x itself is a reference variable, which means reference variable x. This is a reference variable. It is referring to what? The object talla. The talla, real, talla is here. This is a memory. This memory is heap. This memory type is stack. I already told you. Don't get confused. Stack and heap, if it is confusing you, just just know that these are two different places of memory, or two different pieces of memory. But here, this is one string. Here is a multiple strings. So this one is referring to multiple references. So args is a variable that is referring to multiple references. This is one reference, the another reference, the another reference, and each one is a string, and there is another string, this is another string, this is another string. So if you keep four strings, for example, okay, args0, args1, args2, args3, each one is a reference again here. All these are references. This itself is a reference. So now the real strings are here. They don't need to be consecutive. They are different locations. But this is consecutive. These references block, that is a consecutive memory. This is a variable name. This is the array. So, and this is the array of type, whatever it is. So let's look at some examples. So the minute you write down here a definition like this, it is, we should look at two things. What is this? It's a class. So what is this? It's an array. Immediately you should recognize that this is a variable, reference variable, days is a reference variable. That's a memory which is allocated. And because this is a class, itself is again references. You get the reference variable for a class, which means that, and this is an array of references. You should always recognize the difference between class type and primitive type. So these are references, and each one will refer to a string. I can say Sunday, Monday, Tuesday, or whatever. Sunday, Monday, like that. This is one piece of memory, the another piece of memory. These are written down, okay, in the heap. And this itself is also goes to heap. That's in the stack. Because this definition is inside two curly braces somewhere in your program. So go to the second example here. This one is primitive. This one is array. This is a reference variable grades. And how many grades are integer? Whatever number of grades you are going to define later on. That's how you get. But right now, as you're defining, what you're defining is basically, okay, a variable. Not really like all that I was explaining you was not even allocated, to be honest with you. What is allocated is, let me go to the reality check here. There's only one variable definition. That is a reference variable. That's it. This is a reference variable. Again, this is a reference variable. This is a reference variable. That is a reference variable. So, you know what? This one refers to, because this is a class and that is an array. So that means this days is going to refer to a set of references. This grades is going to refer to set of integers. And the heights are going to refer to the set of doubles. The args is going to refer to set of references of type string. So Monday, Tuesday, Wednesday, Thursday, Friday. So how are you going to define? So this is a reference variable. These are all the objects which are going to be defined. Each object is a string here, right? Okay, which object of a string, which means that this is going to be referred to by a reference, another reference, another reference. You have 7 references. Those references will be actually pointed, shown by the days. So when you are writing down days is a reference, and that is actually pointed to the 7 references. Reference 0, days 0, Days 1, days 2, 3, 4, 5, okay, 6. Day 6. 0, 1, 2, 3, 4, 5, 6. Days 0, days 1, days 2, like that. And each one is going to be, because this is day 0. This is days 1. So day 0 is a reference which will refer to Monday. Days 1 is a reference, is referring to Tuesday. Like that, the whole thing. So you can even define in so many different ways if you want to. I'm allocating memory for references, 7 references. This is square bracket. Don't forget that. Don't mix it with, okay? Square bracket means array of references. So look at here. This memory is this one. When you write down this one, this sentence, for example, what is being allocated is memory for days. And then that will point to 7 references. That's all being allocated. Okay, days 0, days 1, days 2, 3, like that, days 6. Okay, days 6. Okay, these are the references. These are all references. They are not attached to objects, but they are references. They are automatically initialized to null, 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 null. Because you didn't put anything so far, null, 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 null reference. They're all initialized to null references. This memory is allocated on the heap. This memory is allocated on the stack. Because this definition is inside some curly braces in your program somewhere. But this new operator, whenever you see that memory is going to be allocated on the heap, once you remember this fact, you don't need to worry about it because it is the same fact all the time. That won't change. So when you define this one, you only allocated memory for this, which it did. That is a reference to array of references. The second sentence is the days which you created earlier is going to be put in some value into it. Right now, you didn't put any value. This is on the stack. You don't initialize the stack variable. But this one is on the heap, the 7 references, because of the new. Okay? 7 references are allocated. All are initialized to null, 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 because that's on the heap. And that is going to be referring to this. So this one allocated memory for the days. This one allocated memory for this chunk of references. Now you have your responsibility to put one each one of them. You don't put them, you don't get them. I'm just writing down an integer. You can even write down, instead of writing down 7 hard coded, you can write an integer. So now each one, say look at here now. So you defined this one and that one together, and then each of the variables in any order, it doesn't really matter, you have to put this order or whatever. So you allocate as. So what happens here is when you say days, this is days, allocated, memory allocated for this, and 7 references, like that, right? 7 references. So 0, 1, 2, these references. So when you write down days 1, so they will put null, null, null. When you write down this sentence, These are all null, 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 null. Okay? So null is a value 0, 0, 0, 0. You won't write down null there. You write down 0, 0, 0, which means that it is a null reference. It's not a reference. So now days 1 is going to be Tuesday. So you'll be allocating memory for Tuesday on the heap. Whatever reference that comes is going to be written down here. Tuesday. And now the second sentence here is Monday. Like that, you fill in. You don't put, it's already null staying there. So like that. So the initialization, when you allocate memory in the heap, the default values are, if it is a numeric, it's a 0, okay? It doesn't need to be string. It could be any class or class type or object arrays. Then it will be null. So ASCII is 0 character and then Boolean is false. So once you allocate array, you cannot exceed the size of the array. If you do, you know, it's like the exception. Index cannot be negative. It cannot be. Index has to be, okay? So 0, 1, 2, 3, 4. So look at it. That's the index. 0. Okay? So that's the array of 6 days. See, look at last day, string last day. Last day is a reference. And the days, if you remember, there is an array of strings. Okay? Like apple can be kept in an apple. Like that, last day is a string. This is a string reference. That's why you can put that. You can also do like this is a valid one, but you know what? You have to know what you're doing. So when you try to go beyond the array or below the array, whatever, so array out of bounds exception. Grade, these are doubles, for example. Memory is allocated for 5 doubles. So that means, right? What happens if first grade this year and is allocating memory for 8 grade because it's primitive. So memory will be allocated 5 of them, right? 0, 1, 2, 3, 4. So that is 5 of them. So this is 8 bytes each. This one is 8 bytes, that is 8 bytes, this is 8 bytes. All of them are 8 bytes each because they're doubles, right? Because primitive. These are not references. The only reference which is grades is a reference. But these are not reference. These are values. Now 85 you write down here, 85.0, 78.5. Like that you write down all the values. And then these are values. Grade 0 is the value, this value, this value, this value, and value. Values are added together. That is the sum. Sum divided by 5 is the average. Okay, in a for loop, you can write down easily if you like. Okay. Sum is 0 to start with. I equal to 0 to start with. I less than 4. That means I can be 0, 1, 2, 3, 4. As soon as it becomes 5, they can become false. So that means 0, it goes to body. 1, I is 1, I is 2, I is 3, I is 4. So I is 0 to start with. Okay. So then after that it goes here, checks the condition is true, goes to the body, executes, and then goes to the third variable, increments, goes back again. You know the sequence of for loop. And then by the time it comes to for loop, the sum of all 5 numbers. Divide by 5 is the average. So you know what? In a string class, there is a length method. This is a method. Don't forget, this is a method. How do you know it's a method, sir? This is a parenthesis. Look at it. But the array has a variable called length. So that means that the dot notation, if this is an array, dot length will tell you the length of the array. For example, earlier write 0, 1, 2, 3, 4. That is the size of that is 5. So length will be 5 here. Whether you write hardcode 5 or grades.length will be the same thing because the length of the grades is 5, then it is 5. Length of the grades is 10, for example, it will be 10. So writing like this is an advantage of automatically getting the length, that is the important and thing to know. So that will be easier for you tomorrow. You can increase, decrease the size of the array, okay, by recompiling it. Okay, so printing the value, the differences. There is an error here, with the arrays, right? The common error is boundary condition, boundary. People make mistakes in boundary places. Then you go beyond your fence. That's the problem. So you are taking the difference between two numbers, the next number and the previous number. When I equal to 0 to start with, so this will be 1 and that is 0 when I equal to. So that means next number and this number. So the length of the array, for example, let us say 5. That means 0 to 4 is indexes. So 0 to index, right? 0 to 4 will be go to the body. So when it is 4, this is 5. But there is no element 5. So elements are 0 to 4, not 5. That means you will crash your program, index out of bounds exception. How do you fix it? Less than or equal to. That means length of the array, okay? No, not less than or equal to. This is, yeah, that means length is, no, length minus 1. The best way to fix it is length minus 1, okay? Not less than or equal, less length minus 1. Okay, that is the best way to fix. It depends on the size though. The size is basically, yeah, but depends on the logic basically, because you go into the next element or the last, so that's why minus 1, you have to put minus 1. So find the smallest number of the array of integers. Let's go there and try to put it in Eclipse. So you have to declare an array of integers and find out the smallest. I think I wrote down for you. I'll show you. Integer, this is the definition. This is the main. Main is going to be executed. So, okay, smallest result and find the smallest is a method. Is receiving an array of integers. So this is the array of integers. I'm giving that x. That's going to become a here. And the a is the array. You know what? This is the type, right? That is the type here also. They should match. So, and now small equal to first one. And then I don't need to put I equal to 0 because small, I said one of them is the first one is a small. And then I'm starting comparing that with the second one onwards. So as long as less than the length, so if small is greater than ai, then the small equals to, okay, ai. Keep on doing it. At the end, you just return, okay, the small. It will work for anything. That's it. For example, if I say, then 23 will be small. Oh, 10 was a small, sorry. The 10 was a small. I forgot, I didn't see. Okay, let's put 0 here. 23 will become small. Yeah, 20. So like that, right? It automatically, you have to, when you are checking with the, testing the arrays, always test the last one and the first one and the middle one. So your small should be, the first one. And you are testing it, the small should be the last one. And if it is working for first and the last, usually it works for the middle. But test it. There's nothing wrong. Don't lose anything. Okay, that's all for this video. And after I'll post this video and then make another video for the rest of the topic. I'll make I think 3 videos.